Yes, so thank you to everybody. We would like to start because we don't want to let waste time to the speakers and the persons that have been attending. I am sure somebody else will join in the next minutes, but we have to start. And today, so why it is important for me, the webinar of today, not only for the outstanding speakers and for the topics that for me and for our association are important, but also because this is the first time that we involve directly a pharmaceutical company. The people that have followed also my presidency since I have been the president. My idea was to increase the involvement of the pharmaceutical industry because they are a part of a direct part and a strong component of our association. Therefore, it is they do the pharmaceutical industry do research, do capacity building, organize events, and so on. And therefore, I decided from the beginning to increase this involvement. And Boehringer Ingelheim has always supported with many initiatives our association, and therefore this is also the reason that I wanted to start with Boehringer for this in this sense. In the meantime, I see that there are new entry in the attendance. There are many that are from African countries. I see from Nigeria, from Ethiopia, from Tunisia, and then also some. I don't manage to see all the name in the. So let's start with our webinar. So the webinar of today, as usual, is composed of two parts. The first is a presentation of one of our members, and the second part is a scientific part. So, and we have two outstanding speakers. I started to introduce the first, and then we will follow with the second. So the first is Professor Beriku Gebrekidan, is the former dean of the University of the Veterinary College of the University of Mekelle. He was a contact person, the Ethiopian manager of the Afro-UN, that is the African One Health University network. He is in the board of the Ethiopian Veterinary Association, our member, and is also in the board of the Tigray Development Association. The Ethiopian Veterinary Association joined the World Buiatric Association 2 years ago, and we are very happy for that because many of you know that I'm trying to increase again also the involvement of the African countries. Therefore, I am trying to push the African countries, the African Veterinary Association or Buiatric Association to join us. Therefore, I'm very happy to start this webinar with Beriku, that also is a very good friend of mine. We have been working together for many years in different projects in Ethiopia, and therefore this is also another reason why, because I'm very happy for that. And then in the second part, but I will introduce Dr. Alnahrawy after the first presentation. He will present us another very important problem all over the world. So not eventually not really in all countries, but in many parts of the world is a very strong, a big concern. Therefore, Beriku, I give you the word, the floor. So I'm happy that you will you can show us the Ethiopian Veterinary Association and the Buiatric Ethiopian context. Thank you, Beriku. The floor is yours.
Thank you very much, Professor. Can you hear me?
Yes, and we can also see you if we go. You have your mobile phone open.
Yes. Yes.
Thank you, Beriku. Go on.
Thank you. Thank you very much. First of all, I want to appreciate the the World Buiatrics Association, one, for giving me the chance to present today. Second, for focusing on Ethiopia and Ethiopian Veterinary Association as well. Thank you for the chance you gave us. I hope today it is virtual, and then I hope we will make it in person here in Ethiopia. And you all are invited to come to Ethiopia and discuss with the Ethiopian Veterinary Association in person here in Ethiopia. Saying this, I can go to the today's presentation as per the request from the World Buiatrics Association. I'm going to take you through the Ethiopian Buiatrics, the ruminant health and production, and also the Ethiopian Veterinary Association context. Welcome to, can you see my slide? One. Peter.
Yes, we see your slides.
All fine.
Wonderful. Thank you very much. So, welcome to Ethiopia. Ethiopia here is the country that I'm going to talk about. Ethiopia is the country with over 130 million people and over 174 million ruminants and more than 56 million chicken. And if you want to fly to Ethiopia, you can use this Ethiopian airline, and you can see how connected Ethiopian airline Ethiopia is through the Ethiopian airline. This is international route, and when you arrive in Addis Ababa, you can use again the Ethiopian airline to go to all directions of Ethiopia, to all parts of Ethiopia. We have the local flights here in Ethiopia. And in fact, after reaching Addis Ababa, you will find the base of Africa. The African Union office is here in Addis Ababa in Ethiopia. And coming to Ethiopia is a gateway to Africa. In fact, after reaching Addis Ababa, you may continue your travel, not through by car or by flight, or maybe you may also continue your travel by the animals, the livestock resources we have. There are places that cannot be traveled by plane or by car, but you can use also our livestock resources here in Ethiopia. And then you will appreciate the incredible historical places in Ethiopia, like the Aksum, the obelisk Aksum, and also the Lalibela Church. These are very, very incredible historical places here in Ethiopia. Similarly, you will see also Ethiopia, the incredible landscape, and the world's hottest settlement in the globe is here in Dalul. And you will see some unearthly things that you maybe wonder about that, and come and see it. When we talk about the livestock here in Ethiopia, you may be surprised that these all 8 animals use the same river to drink. 8 types of animals, 8 types of species. You can see here in this small river, we can appreciate everything. We have a camel, donkey, sheep, horses, goats, mules, cattle, in a single point. So this is a system we have in Ethiopia that you don't see in other places or in the Western. And if you want to see this place, you can come and visit us. Well, Ethiopia is known by huge resources of livestock. We have the huge cattle population, the goats, sheep, and mule. And Ethiopia is a very, very big resources here globally and nationally also. You can see these are the animals, the local animals we have in Ethiopia. The Bagait cows are very good in milk production and beef, and the Boran cattle originally here in Boran, and also the Fogara, the Raya cattle. We have a lot of animals in them, and you can come and appreciate the same thing. So this livestock resource in Ethiopia, not only an economical revolution or economic sustainability, but also it is a way of life here in Ethiopia, because the economic national GDP contribution of the livestock in national GDP is very huge. And also the 80% of the households in Ethiopia are dependent on animals. So nutrition, income, and resilience of millions of animals, but also they also contribute in draft power, in organic fertilizers, and also social security. Like you can see, the agricultural practice is facilitated and supported by the livestock, mainly, in fact, cattle. So when we see there are huge world-class herd size, but low productivity per animal. It needs some support. And also there are a lot of animal diseases here. The feed security is another problem. The veterinary service is expanding from time to time, but still there is uneven and also limited resources. So there are a lot of local breeders that need support or improvement, but they are a foundation, a very strong foundation for improvement here in Ethiopia. When we see the support from government, there is now currently a very huge policies. There is very big policies and also resources here supporting initiatives like the policies and initiatives from the government. There is a green light from the government, like the livestock development plan. We have also a 10 years development plan for livestock development and others. And there is also a very good initiative, the bounty of baskets, and that transforms dairy and meats and others. There is also a One Health strategy plan approved by the ministerial level. Similarly, we have a national One Health programs differently in vaccination, surveillance, and disease control. We have also a public-private partnership. So there are a very good policies and initiatives that can support the livestock development here in Ethiopia. Africa, when Ethiopia's contribution to African development, you can see Africa's largest livestock population here is here in Ethiopia. And the continental disease control is, Ethiopia is supporting for disease control in the continent. And we have also a very huge universities, and Ethiopia is again a regional veterinary education hub. And strategically, Ethiopia is found in the geographic gateway to the Middle East and other market areas. In fact, there is also many universities, and the Ethiopian Veterinary Association is helping and supporting many activities in the livestock system here. So when you see the Ethiopian contribution at African level, and why Ethiopia is the basket for the livestock, you can see here the rank of livestock production and livestock population in Africa. In cattle, it is the first cattle population in Africa. In donkey, it is the first population in Ethiopia again. In Africa, Ethiopia is the first in cattle, the first in donkey, the first in goats, the second in sheep, the second in horses, the first in camel production, and also the first in bee colonies in Africa. So this all shows that Ethiopia is the best place to come in and to start with and expand to other parts of the African countries. So when we say Ethiopia is the largest livestock producer in Africa, it is by reason of these all things. So we have huge resources in livestock. And we, as a country, Ethiopia contributes to African livestock disease prevention, because we have in Ethiopia, we have a very strong institute that produces vaccine. This institute is called National Veterinary Institute. And you can see how this institute produces and distributes to the whole Africa. This institute distributes vaccine to 33 countries in Africa, and in fact, sometimes in Middle East. So working with this institute on National Veterinary Institute means working with other Africans and reaching to other African countries. And when we see the regional veterinary education hub, Ethiopia is leading by number of higher education veterinary training institutions in Africa again. You can see this data is found from the reports of the countries. In Ethiopia, we have 26 universities giving veterinary degree and 19 colleges giving a degree on paravets, animal health institute. In total, we have about 45 higher institutions that give veterinary or animal health trainings. I have not included the animal science colleges, but this is only veterinary. But you can see the other African countries like Nigeria, 19, Egypt, something, and Kenya, and so on. So in the veterinary education and veterinary training institutions, Ethiopia is also leading in Africa. This is the data found from the World Health Animal Health Organization. World Organization for Animal Health reported that the number of universities in each country, and Ethiopia has the highest number reported in the as veterinary establishment education in the WAB. And when we see the linkage, local livestock markets in Africa, you can see there are the outways from Ethiopia, like to Eritrea, to Sudan, to South Sudan, to Kenya, to Somalia, and Djibouti. There are many ways how to connect with other African countries, even with this livestock trade system. This shows that the transboundaries are very important, and the economic integration of these neighboring countries, like especially in the Horn of Africa, is very important. Internationally, Ethiopia is now and use it and have a potential for the future to export livestock systems to the Middle East, to the Asia and Europe, and also the Brazil and other Americas. There is a potential that's to show this. So when I come to the Ethiopian Veterinary Association, frankly speaking, I am very proud to speak about the Ethiopian Veterinary Association. Why? Because it is a very big institution that sustained for the last 50 plus years. So Ethiopian Veterinary Association was established in 1974 by a very visionary, certain members of veterinarians, a very visionary, very few, but very visionary veterinarians. And now we have about more than 2,000 veterinarians as a member of veterinary association in Ethiopia. So it is about plus 50 years. So this is a structure we have now, a very big structure. We have the boards and also executive and also directorates, the facilities, and so on. You can see the Ethiopian veterinary management here. We have the executive board members, about 7 executive board members elected by the members, General Assembly. And also we have about 9 staffs, secretary staffs, led by the CEO, Professor Andreas, and the board is led by the president, Dr. Boja, is the president. And not only these staffs, but also we have a very strong journal and research outputs managed by this 9 board of editorial board of the research and the journal. And what we do and activities here, one, we as a veterinary association, we do the professional development and advocacy by organizing the annual conferences, the trainings, workshops, to update the veterinarians on the latest practices and also researches and lobbying and connecting with the higher officials. This is a very big assembly that we do every year. And also we supported the private sector, linking with the policy makers, the private sector veterinarians involvement and others. And we also link the higher officials ministries with the private sector to show and advocate how veterinary private sector is important. And the policy advocacy, as a veterinary association, we helped in supporting the proclamations, policies, guidelines, standards, and advocate with the government, and also not only advocate but also help in preparing the standards and the guidelines, and also, in fact, the ethics, the standards as well. The capacity building and training, the veterinary in partnership with others, we also provide the trainings and different levels and different curriculums in improving the animal health, improving the welfare of the animal, and also including the One Health system in the country. So connection, also the international and national networking connection is there. Our association, Ethiopian Veterinary Association, is a member of the World Veterinary Association, and also thanks to the World Association of Buiatrics, Ethiopian Veterinary is also now become the member of a World Association for Buiatrics, and we are connecting internationally, but nationally. As a veterinary association, we are working with many associations in the country and also with the ministerial levels of the government, as well as with the universities in Ethiopia.
Okay.
And this is a very good, this is another outway, that's the research and the dissemination. We have here the Ethiopian Veterinary Journal, very strong journal in the country, and we do.
We have lost Beriku. Beriku.
You lost your sound.
Yeah, I call him.
So good afternoon in the middle.
Just a moment, I try to call Beriku.
Sorry, today we have unstable connection in Ethiopia, and not this particularly.
Yeah, it was so good so far. Hello, Professor.
Yeah, good afternoon from Ethiopia. How are you, Professor?
I'm fine. I'm fine.
Hello? Hello?
Hello, Beriku. Yes,
Nice.
yes, we have lost you. Now it's okay. Perfect.
Sorry.
Sorry. Can you see my slide?
Can you see my slide?
Not anymore.
Not yet.
Sorry.
But in the meantime, I can greet all the guests that in the meantime have joined us. Hello, Mohamed. Hello, Professor Sherif from Tunis. Okay, Beriku,
Yes.
let's continue.
Your slides are back.
Yeah, you are back now.
Yes.
Thank
Beriku,
you.
go on. Thank you.
Yeah. I hope you can hear me now. You can see my slides and you can hear me now.
Yeah, that's fine.
So we hear you, please. Go
Wonderful. Thank you. So the other very important thing that Ethiopian Veterinary Association is doing effectively and sustained for the last many years without any interruption is the research, education, and knowledge sharing through the Ethiopian Veterinary Journal and bulletins and proceedings to disseminate the researches and the best practices among veterinarians and also beyond the veterinarians, because this research output is disseminated online and disseminated to all universities in Ethiopia as well. So this, you can see, this is a Ethiopian Veterinary Journal and the bulletin, the proceedings. We have conducted 39 annual conferences that you can imagine. We had 39 proceedings and beyond that, and the journalists are always there in this. So what I can say here is Ethiopia's strategic advantage in livestock and veterinary service is huge. Why? Because there are enormous livestock resources here in Ethiopia, and we can work on it. And the genetic diversity, especially the indigenous cattle, are very huge, like the Borana cattle is known here in Ethiopia, the Bagait, the Fogara, the RC breed, and other breeds we have in Ethiopia are very good opportunity for selecting, breeding, and research in tropical animals. So anyone who wants to come and appreciates and do the research in this genetic diversity of Ethiopian local cattle is welcome. And the government of Ethiopia is also very committed now. There is high-level support from the livestock sector of the ministry. So we have also this a very good opportunity, and the market is very, very good and emerging, especially in the Middle East, in the African and others. And there is human capital grows here because we have many universities, and the veterinary education as association is also a very strong that can collaborate and implement activities here in Ethiopia. So I kindly and politely call for partnership with Ethiopia. I can say, let's come and do the things here, because let's establish a partner with Ethiopian Veterinary Association, and then we work very good in science and in practice also. And also we can collaborate with Ethiopian universities. We have many universities. As I told you, we have more than 26 universities providing veterinary degree. You can come and collaborate with all universities. The Ethiopian Veterinary Association can serve as a bridge to connect with all the universities. And let's come and create a solution for the Buiatrics, for the One Health and food security as well, especially the climate system here, because we have many problems because of the climate system. 2 years ago in Borana, we lost many thousands of animals because of the climate system and drought. And so normally we are asking for shared value, like mutual learning, mutual research and collaboration, that we can work together. So this is a time to act now. Come and be partner or invest in Ethiopia in any way, in research, in capacity building, in investment, and in bringing your products and working with Ethiopian Veterinary Association for mutual benefit. Thank you very much, Professor.
Beriku, thank you very much. We already knew that the Ethiopian Veterinary Association is an outstanding and very active association. I know very well, and this was also the reason why we are trying also to push not only Africa but Ethiopian Veterinary Association to be collaborative with us. And I think everybody knows my dream of having an African Buiatric Congress very soon. So a regional African, the first African Buiatric Congress that I hope we will be able to organize in 2027. It will be a big challenge because it is not easy. It will not be so easy, but for sure, this is our commitment. This is our challenge. Beriku, we have to do this. And Ethiopia, for what you have just said, you have mentioned the number of animals, the number of persons, also the political role of Ethiopian country in Africa might be the first hub for starting this strong collaboration between African countries and the World Association. We have just some minutes before going on. Can you, Beriku, you mentioned the problem at the end of your presentation. You mentioned the problem of that you have experienced recently. Can you just mention what are the most important health challenges for the ruminant population in Ethiopia?
Well, good. Thank you. For the health issue, we have many animal health preventable, in fact, animal health problems. So some of them are the FMD. We have the FMD problems that we are experiencing, and especially the I can go to the challenges we have, the diseases we have are FMD, the limpy skin disease, and the PPR here, the mastitis, and especially now currently there is outbreak in northern part of Ethiopia. Many animals are dying because of LSD, the limpy skin disease, and here and there also the FMD is happening and affecting a lot of animals. The mastitis is another problem. So these are preventable diseases, in fact, but because of the lack of accessibility and sometimes disconnectivity of the vaccines. and the access of the vaccine. There are some problems here, but mainly we can say is there may be a lot of animals here and there, animal disease here and there, but currently FMD, LSD, PPR, and the mastitis are some of the very problematic diseases.
Thank you. It seems to be that also in Europe we start to have similar problems to you, because when you say FMD recently in Germany and Eastern European countries, lumpy skin disease, oh my God, in Italy, France, and so on. And the PPR also recently, that is a huge challenge, a huge risk for us. Okay, mastitis is a daily concern for all pediatricians. Therefore, it seems to be that we share many challenges, many problems that we have to solve together. Thank you, Beriku. I think that also trypanosomiasis may be a concern,
yes,
perhaps for Ethiopia.
Yes.
And therefore now, thank you, Beriku. In the meantime, I would like to greet all the people that joined from different parts of Africa and of the world. I hope that Norma is still has not fall asleep yet, because in New Zealand is very late in the night. So therefore now, thank you to the new participant, but we move to the next topic, that is trypanosomiasis, veterinary significance in a One Health context, with Dr. Alnahrawy. Dr. Alnahrawy is from the Boehringer Ingelheim, is technical manager for ruminants and veterinary public health in the IMETA region, so India, Middle East, Turkey, and also Africa. Is a veterinary, very expert with over 30 years of experience in ruminant health, nutrition, dairy production. And he is a PhD in veterinary microbiology, and he is specialized in immunology, post-vaccination monitoring, mastitis, milk quality, and today we asked him, his name was suggested to me from other colleagues, so therefore we are very happy to have Dr. Mohamed Alnahrawy, and therefore I think we are starting to open the presentation. Dr. Alnahrawy, so thank you very much for having accepted our invitation, and the floor is yours.
We can see your slides.
Yeah, this is the slide. Okay, do you hear my voice?
Yes.
Because I lost
Perfect.
the connection for 1 minute, so that's why I'm asking. Okay, hello everyone. Before we begin, I would like to sincerely thank the World Association of Buiatrics and Professor Gentili for the kind invitation to share this important topic. In fact, trypanosomiasis is more than a disease. It is a silent disruptor of animal health, livelihood, and ecosystem as well. Today, we will try to uncover how this parasite connects veterinary medicine, human health, and environmental balance. In a world where boundaries between species and environments are fading, particularly after the climate changes, understanding trypanosomiasis is not just science, it is survival in my mind. Let us unveil its secrets together. So it is a One Health topic. It is a One Health context. And at Boehringer Ingelheim, we strongly believe in the One Health approach, because the health of animals and the human is deeply interconnected. That's why the family, I mean Boehringer family, because we are a family-owned company, continues to keep animal health and human pharma united under one vision, improving lives through generations for better health of all. So I am trying to move to the next slide. Yes, this is the agenda for today. we will have a look about the trypanosoma originated as a One Health, as we will see from the coming slide. And we will tackle the trypanosomas of veterinary importance. And then we will go to the clinical picture of trypanosoma, which is very unique. And finally, we will go through the treatment and control options we have. So the origin of trypanosomiasis was initially a One Health topic. And I will start to warm up with this simple quiz. And you can share your information, or if you know the disease I am speaking about, you can share in the chat. And of course, Peter can tell me if someone write a specific topic. So this disease led to the establishment of the first veterinary school in France in 1762. It is a Morbelli virus, single-stranded, negative sense RNA, with one serotype and 3 lineages. The virus causes acute, highly contagious disease of cattle, buffalo, and a variety of wildlife species. And then in 1880, infected cattle originated in India introduced the virus to the African continent in Massawa Airport, now in Eritrea. This will lead to death of 90% of the cattle in sub-Saharan Africa, including sheep and goat. And what happened after that? There is a mass human starvation, killing 1/3 of the human population in Ethiopia and 2/3 of the Maasai people in Tanzania. And because of this drastic reduction in the grazing animals, thickets formed in the savanna that served as a breeding ground for the tsetse flies, the vector of the human African sleeping sickness. So it originates from here, the trypanosomiasis. And of course, this disease is rinderpest, or the cattle plague. So initially, trypanosomiasis is a One Health topic. Now, rinderpest was fully eradicated in 2011 after the FAO rinderpest eradication campaign that started earlier in the 90s because of the very potent vaccine, thanks to Dr. Walter Plurite. Now, we live in a world without the rinderpest. But trypanosomiasis remained widely geo-distributed. And we succeeded to eradicate rinderpest with the potent tissue culture vaccine, but we cannot make a vaccine for trypanosoma. In the coming slide, we will try to explain why. Looking to the geography of the trypanosomosis, the most widely distributed type is Trypanosoma evansii. Trypanosoma evansii is the first known pathogenic trypanosome, first known in India as the cause of surra, the widespread in tropic, and also it is transmitted only mechanically. And we will speak in some detail about the way of transmission of the different types of trypanosomes. Some can be transmitted mechanically, some can be transmitted biologically and mechanically. In Africa, Trypanosoma prussii, congelensi, and the vivax are the main pathogens for the animal African trypanosomiasis. And also the human African trypanosomiasis transmitted by the tsetse fly, mechanically and biologically. In general, Trypanosoma vivax is more commonly encountered and more pathogenic in West and Central Africa, whereas Trypanosoma congelensi appears more prevalent and more pathogenic in the East African countries. Recently, with the climate changes, two reports, one from Mali and the other one from Nigeria, where Trypanosoma congelensi was found to be more prevalent than Trypanosoma vivax in the studied herds. Trypanosoma vivax is also transmitted mechanically by biting flies and has been responsible for disease outbreaks in Costa Rica and in the South American countries, including Bolivia, Venezuela, where it affects mainly cattle and sheep. In cattle, Trypanosoma vivax generally produce higher level of parasitemia than the other species. And because its life cycle in the tsetse fly is also shorter, Trypanosoma vivax is more readily transmitted than others when animals are newly introduced into a tsetse infected area. Higher parasitemia also facilitates the mechanical transmission of Trypanosoma vivax. The relative abundance of wildlife in East Africa particularly, compared to West Africa, may explain, at least in a part, why the prevalence of the disease appear to be declining more rapidly in the west side. The impact of the African trypanosomiasis, African animal trypanosomiasis, is huge. According to the government estimation, more than 3 million cattle estimated to be killed by the African trypanosomiasis annually. And the direct losses due to this massive death of cattle may surge up to $1.2 billion, while the total package of losses may surge up to 4.7 or 5 billion US$ per year. So it's a huge impact on animals and consequently in the human being that are very well connected with those animals. Looking to the position of Trypanosoma in the parasitics of cattle, generally we have three cattle parasites, three big categories: the helminthids, the arthropods, and the protozoa. Of course, Trypanosoma lying in the protozoa side, in the blood protozoa. We have the Babesia, the Filaria, and Trypanosoma. And Trypanosoma live outside the red blood cells, not inside the cells, which make it very vulnerable for the antibodies, very vulnerable for the phagocytic cells. But why they are not able to deal with the Trypanosoma, this is what we'll highlight it during the coming slide. If you look to the blood protozoa, you will find a missing species here, which is anaplasmosis, because we discovered after all of these years that anaplasmosis is no more protozoa. Anaplasmosis is a gram-negative intracellular, obligatory intracellular bacteria. For many decades, it was included in the blood protozoa, but now anaplasmosis is bacteria, gram-negative bacteria. So the trypanosomes of veterinary importance, particularly that cause under the disease of Nagana in Africa, the African trypanosomiasis, which mainly affects the tropical Africa. The species that cause this Nagana is the Trypanosoma prosi, Trypanosoma congelensi, vivax, simii. And the main vector for these Nagana trypanosomes are the Glossina species and also other biting flies mechanically. We have also the Surra, which affecting the horse, camel, and buffalo, caused by Trypanosoma evansi, also in Africa, in Asia, and South and Central America, and it is transmitted mainly by the biting fly mechanically. Then we have the durine in the horses and the donkeys in Africa and Asia and in South and Central America, which caused by Trypanosoma equiperdium. And the main vector here is not by flies, it is transmitted venereally, only by the venereal route. And we will know why in the coming slide. While we have some non-pathogenic trypanosomiasis present in worldwide, like the Trypanosoma fileri and Trypanosoma mylophagum. And also it can be transmitted mechanically by the biting flies. It is not our topic to speak about the ruminant trypanosomiasis, but we have to make just a look for it. We have the Rudinsian sleeping sickness and the Gambian sleeping sickness that caused by Trypanosoma rudinsi and Trypanosoma brucei gambiense. And they are both transmitted by the Glossina species. However, we have the Chagas disease in human and also in dog, cat, and pigs in the South and Central America. In southern United States also, caused by Trypanosoma cruzi. If you look to the evolution of the Trypanosoma, you will find it started with Trypanosoma brucei, and Trypanosoma brucei have a way to live outside the host. Trypanosoma brucei have like what we call a big mitochondria, a big kinetoblast that enable the species to live outside the main host. While Trypanosoma evansai are not able to live outside the host, it's only transmitted mechanically. Why? Because it has a very little kinetoblast that cannot enable it for the reproduction outside the host. When it lost this kinetoblast, then it will not be able to be transmitted even mechanically, only through the venereal route like the Trypanosoma equiperdium. So this is the main difference between the different types of Trypanosoma and why they are transmitted sometimes mechanically, why they are transmitted sometimes mechanically and biologically. If we look to the morphology of the Trypanosomas, the first known Trypanosoma is the Trypanosoma evansai with a very small kinetoblast and a very well-defined flagellum. The smallest one is Trypanosoma congelensi. They have some morphological difference related to the appearance of the flagellum and the size of the trypanosome. So the smallest one is Trypanosoma congelensi. In acute infection, Trypanosoma vivax is usually numerous in blood and can be identified by its very fast movement in the wet film. Trypanosoma congelensi is smaller, of course, and it is sluggish in wet film and often adhere to the red blood cells by the anterior end. While Trypanosoma brucei is large like Trypanosoma vivax, but its rapid movement is confined to a specific area of the wet film, not on the whole wet film. There is another type, Trypanosoma simii, which is morphologically undistinguished from Trypanosoma congelensi, and it is adapted only to pigs, in which the parasitemia can be very heavy. We called it a swarming effect. So the life cycle of the trypanosoma inside the tsetse fly is very, very characteristic and very special. The tsetse fly can be distinguished from other large flies by two easily observed features. Primarily, tsetse flies fold their wings over their abdomen completely when they are resting, like this picture, so that one wing rests directly on the top of the other. Secondly, tsetse flies also have a long prospects extending directly forward. Tsetse flies have unusual life cycle, which may be due to the richness of their blood food sources. Both the male and the females of the tsetse flies feed on blood. Usually the flies that feed on blood, only the female, but the male likes the sugar and something like that, except for tsetse flies and also for Stomoxys. Both the male and female feed on blood. The female tsetse fly mate just once. This is very important in the control, by the way. Why? Because making this trial insect technique is a very valid and sustainable method for the eradication of the tsetse flies. So the female of tsetse flies mate just once, and after 7 to 9 days, she produces a single egg, which develops into the larva within her uterus inside the fly. About 9 days later, the mother produces the larvae, and then the mother produces the larvae after 9 days. And then during this time, the female feed the developing offspring with a milky substance secreted by a modified gland in the uterus. About 9 days later, the mother produces a larvae. The mother produces a larvae which burrow into the ground where it pupates. The mother continues to produce a single larvae at roughly 9 days interval for her entire life. The adult fly emerges from the pupa in the ground after normally 30 days. Over a period of 12 to 14 days, it matures, mates, and if it is a female, deposits the first larva. Then 50 days elapse between the emergence of one female fly and the subsequent emergence of the first of its progeny. This slow rate of reproduction means that tsetse population can be eradicated by killing just 2 to 3% of the female population per day. And remember, this small monster occupy 10 million square kilometers of Africa, involving 38 countries and placing 50 million cattle at risk. Also remember that the Stomoxys is the vector of the Trypanosoma evansi in all species, particularly in camels. And both the male and the female feed on blood, but the life cycle is normal, not like the tsetse flies. So the immune mechanism is very, very characteristic for the Trypanosomas. For the Trypanosomas, they have 3 special immune mechanisms. The first one is the antigenic variation, which is the ability of the trypanosome to periodically replace the outer monolayer of their protective coat of the variant surface glycoproteins. That's why the animal, when the animal forming antibodies, it will not be fit for the next generation of the trypanosome. That's why the animal makes a new antibodies and so on. The animals also recovering from the infection with one strain of trypanosome are not immune to infection with another strain. Why? Because of the variant surface glycoprotein is different. And this is also why we couldn't make a vaccine for the trypanosoma until now. The second important immune mechanism for the trypanosoma is the thiol redox system. Because the trypanosoma live outside the cells, it is an easy target for the antibodies which escaped from it through the antigenic variation. And also it is an easy target for the macrophage and the phagocytic cells. But due to the thiol redox system, the trypanosoma can deactivate the reactive oxygen species of the macrophage and the other phagocytic cells, whatever it is, superoxide, hydrogen peroxide, single oxygen, hydroxyl radical, it will be deactivated through the thiol redox system. Because of the thiol redox system and because of the antigenic variation, the immune system of the animals become very exhausted, and then immunosuppression occurs. A complete status of tolerance. So the infected animals are more susceptible to the secondary infection by other microorganisms, particularly the bacteria. That's why when we will speak about the clinical picture of trypanosoma, we can notice that any other disease could be expected. If we are in an area of trypanosoma, we can expect any other clinical symptoms. Why? Because of the immunosuppression happened by the trypanosome. The incubation period of the trypanosoma is from 8 to 20 days. And the morbidity is more than 70% in cattle infected with trypanosoma vivax, and up to 100% in pig infected with Trypanosoma somii. Morbidity is much lower in sheep and goat and horses because they are not often the preferred host for the tsetse or less exposed to tsetse challenge. The mortality may reach up to 100% if not treated. And remember that Trypanosoma evansi prefer camel in the Gulf region. It can infect camel, cattle, and all other species, even dogs and cats. But in the Gulf region, for a reason or another, they prefer the camel blood. So the basic clinical syndrome, the first very early clinical signs is the chancre. Chancre is the inflammation in the site of the biting of the tsetse flies, which is not readily very noticed under the field condition. It is very well known in human beings, but not very well noticed in cattle. But with careful observation, we can notice the chancre. And then we have fever spikes after the incubation period. Of course, we have fever spikes. And the period between spikes and the spike is more than 7 days, 8 to 9 days. At this stage, we'll have watery and the ocular and the nasal discharge and the loss of body condition despite good appetite at this stage. And this fever spike is corresponding to the formation of the new antibodies. When the animal changes the outer membrane, then new antibodies is formed, decrease the number of trypanosome in blood, so no fever at that time, but after a while, the microbe change the outer membrane and make a parasitemia again, and then the fever start to appear. Then after this basic clinical syndrome, we have the anemia stage, which is very, very characteristic for the trypanosome. The mucous membrane became pale, And also the superficial lymph node become visibly swollen, especially in the African trypanosomosis. It is not that case in Trypanosoma evansi. There is no enlargement in the lymph node normally, but in the African trypanosomosis, there is a superficial lymph node become visibly swollen. And then we can have diarrhea, occasionally occur. Some animals have edema, and we will speak about particularly about the edema when we tackle the treatment of the trypanosoma, because we find in field, we find some connection between some types of the treatment and the development of the edema in the early stage. Because usually edema is happening in the late stage, but sometimes we can notice edema in the early stage. Then during this stage of anemia, the estrus cycle becomes irregular, pregnant animal may abort, and semen quality progressively deteriorated. And there is a progressive drop in the bagged cell volume, which is a very, very characteristic for the trypanosoma infection. In the chronic phase, there is some thin and rough-coated anemic lethargic cattle with generalized lymph node enlargement, are reported to have they called it the fly struck appearance. We'll see it in one moment in the coming slide. With complete milk loss, no working capacity, and the animal become very emaciated, particularly in the thigh muscles. That's why it calls the disease Maldicaderas syndrome in the Latin America. And then the animal will die within 2 to 4 months is no longer. Some cases showing nervous manifestation with convulsion and paralysis, because the trypanosome are able to cross to the CNS and the cerebrospinal fluid. We have to notice that the mixed infection with more than one species of trypanosome are very common, and are usually more severe, come with more severe symptoms. The intercurrent bacterial and viral and or parasitic species may also mask or complicate the basic clinical picture, because as we said, we will have a case of immunosuppression. That's why in the region of trypanosoma, we advise the veterinarian to use a trypanocidal therapy before trying any kind of treatment. Even if the vet found some kind of pneumonia, he have to treat trypanosoma at first, because it might be very well linked to the immunosuppression caused by the trypanosome. In conclusion, the clinical picture is anemia, tissue damage, and immunosuppression. Look at some photos for the infected animals with trypanosoma. The emaciation, the Maldicaderas is very clear here, particularly in camel. Also, you can notice the edema, and the anemic animals cannot stand sometimes. Also, you will have the same picture in cattle, in buffalo, in horses, in pigs, and even in dogs. So for the treatment, we have several trypanocidal drugs are available. Some of them are very old and they became not effective due to the development of the resistance, and some still active against some kind of the trypanosomes. So the oldest one is the diaminisin aceturate, which can be given intramuscular or subcutaneous, and the dosage is from 3 to 5 up to 8 in the resistance cases of trypanosoma, particularly for Trypanosoma evansi. It's indicated to the congruency to Vivax, less effective in Trypanosoma brucei and Trypanosoma evansi. And the adverse effect of the diaminisin aceturate is that it's toxic for horse, dog, and also for camel, particularly in the high doses, the 8 milligram per kilogram. In case of relapses for the treatment with diaminisin aceturate, the best choice here is the isometamedium chloride. The second drug for trypanosomal drug is the humidum bromide or chloride, which can be given intramuscular or intravenous, intramuscular in cattle, intravenous in sheep, goat, and pig, with the dose of 1 milligram per kilogram. indicated for congelency, vivax, and less effective also in Trypanosoma brucei and Trypanosoma evansii. It is very toxic to horse and the potential carcinogenic. And for the treatment of relapses, we may use diaminazine aceturate or isometamedium chloride. Isometamedium chloride, which is widely used against Trypanosoma, is only indicated intramuscular, but it's also a little bit irritant. So that's why some veterinarians might inject it off-label intravenous, which is not recommended at all because the pharmacodynamic and the pharmacokinetics will be changed. And the dosage is 0.25 to 1 milligram per kilogram according to the degree of resistance of the trypanosome to the isometamedium chloride. It used with success in congelency vivax, but it is very less effective in Trypanosoma brucei and also in Trypanosoma evansii. The isometamedium chloride is toxic above 2 milligram per kilogram. And we have to avoid the subcutaneous, as I said, because it is highly irritant. And the treatment of relapses in the cases of the isometamedium chloride, you may try the diaminazine aceturate. Then we have the category of the quinabiramine compound, the quinabiramine sulfate, quinabiramine chloride, and a combination between quinabiramine sulfate and the chloride. This is one of the oldest trypanocidal drug used, but it withdrew from Africa since the 70s because it creates a lot of resistance in a very short time. Why it creates this resistance in a very short time? Because it is not safe. It is one of the toxic chemotherapies. That's why the vets used it in a very low doses, low therapeutic doses. And this is accelerated the process of the resistance against the quinabiramine compound. Can be used against congelency, vivax, evansii, CMI, equiburden, brucei, and also for camels with high doses can be used for Trypanosoma evansii. It is a very toxic drug, and the resistance developed very fast. To use that treatment in the relapses cases with the quinabiramine, we have to try the isometamedium chloride or the suramine sodium. We noticed that if we use the quinabiramine compound in a very low doses, particularly in camel, the edema come very, very early and not in the chronic cases. Because in the literature, it is very well documented that the quinabiramine prevents some important substance to enter to the trypanosome. And then the trypanosome can divide very fast using the stored quantities inside the cell. And the number increased very much in a very short time in the blood. And the trypanosoma start to go outside the blood. And wherever it goes, it will make the edema. And then we have the suramine sodium, which given intramuscularly with a dose of 10 milligram per kilogram. In horse, we have to give 3 doses for the first week. It can be used against the evansii, the brucei, and the equiburden. Sometimes it is toxic to horses. The intramuscular cause necrosis in the injection site. And the treatment for the relapses of suramine, you may try to quinabiramine sulfate. Finally, we have the melarsomin dihydrochloride, which can be given intramuscular to and subcutaneous. It can be given to all the animal species, camel, cattle, horse. In camel, the dose is 0.25 milligram per kilogram. In cattle and horse, the dose is 0.5 milligram per kilogram. And it is very effective against the evansii, brucei, and the equiburden. It is very, very safe, this molecule, the melarsomin hydrochloride. And there is no any kind of relapses associated with the melarsomin. Why? Because this is the only trypanocidal molecule that disrupt the thiol redox system. So it enables the immune system to get rid of all the trypanosome directly after directly after injection. A few minutes, by the way, 30 to 1 hour. If we look to the control plan, we have the Pan-African tsetse and Trypanosomiasis eradication campaign, which aim to reduce the exposure to the vector. This is the first target. Strategic treatment of the exposed animal to make the trypanosome not available for the tsetse flies in most of the cases. And then use trypanotolerant animals. It is not very well successful, these trypanotolerant animals, because the production is very low for this species that are tolerant to the trypanosoma infection. But it is mostly insecticide-based methods. It will never be successful unless it is incorporated with the sterile insecticide technique. Why? Because usually there is a remnant after application of the insecticide. There is a remnant of the female, and this remnant cannot be reached unless we use the sterile insecticide technique, the sterile male technique. Considering that the female only mate one time per its life, so the sterile insecticide technique will be very helpful in the control of the tsetse flies. And it is already applied, a project implemented from 1994 to 1997 in Zanzibar, in the United Republic of Tanzania, and demonstrated after suppression of the tsetse population with insecticide, the sterile insecticide technique completely removed the Glossina ostini from the island. So it's very, very effective technique. A survey has been done in 1999 and also in 2002 and 2014 and also in 2015 and confirmed the success. So the continued absence of the tsetse and nagana on the Zanzibar island. These are the reference in case you wanted to have more information about this fascinating trypanosome. And I thank you very much for your attention, and you are most welcome if there is any question.
Thank you, Dr. Alnahrawy. Very interesting, very challenging. I wanted just to ask, and you came with this issue at the end of the presentation with the trypanotolerant breeds that actually are the ones that produce less, but perhaps is also a good technique for reducing, besides the sterilization of the male. I don't know if you can add something, and if there are some other question, people can go on, can come on. Yeah, please, Dr. If you have some inputs, some insight on this.
Yes, there is some, they found some local breeds which is immunotolerant to the trypanosoma, but in fact, this, I don't remember the name of the breeds. It's also, it's African breeds, but they are not able to produce much more milk, or even the feed conversion rate is very low. So it is not economical at all. But looking to what have been achieved in Zanzibar is very, very promising. The sterile male technique is very, very promising, because the insecticide, as we all know, will develop a very fast resistance, of course, and we will never be able to eradicate 100% of the trypanosome with the insecticide. But the sterile male can fight the last female at any place, and by this, we will eradicate the disease, exactly like what happened in Tanzania, in Zanzibar.
Okay, but how can we sterilize the male?
They used some X-ray technique to sterile the male, and then they yeah.
Ah, that's good.
This is a very specific technique for that, and it is very well known and applied successfully. So I mean, what happened in Zanzibar can be happen in other African countries. And I think the government is working in something like that.
Yes. So we see in the chat, Dr. Kewado Gelebo, trypanosomiasis is a devastating disease, especially to ruminants animal in Ethiopia. So therefore, the connection, the matching Ethiopia and trypanosomiasis was effective. Most of us know it tried our best to control, eradicate the disease, but we failed and still failing. Maybe we are not using the One Health approach. But I think that, Dr. Gelebo, I think that there are some input from the presentation of Dr. Alnahrawy, especially with this sterilizing techniques.
Yeah, sterilizing male technique.
Yeah, in fact, also Tesale, sorry, how effective is SIT in areas where more than 60 species are found? But it seems that it's effective.
Yes, Prof, Professor. Yes. Good afternoon to all of you. I'm Gawado from Ethiopia. Thank you very much all for your nice presentations, especially Alnahrawy. You have addressed in details about African animal trypanosomiasis and its economic impacts. And I just want to comment on how the disease is devastating in Ethiopia, especially for smallholder farmers in rural areas. For your information, the disease is very known to Ethiopia, and many efforts were carried out to treat and control and prevent the disease of maybe over 60 or 70 decades. But still we are struggling with the disease, particularly the PATEC, the Pan-African Sustained Trypanosomiasis Eradication initiative was launched in many countries where the disease is prevalent, and it was also implemented in Ethiopia for more than 10 years. And it was after, it was through this initiative that the sterile technique was introduced to Ethiopia. Now there is a national center in which flies are being raised and sterilized and released into the field. I think the main concept, like he was mentioning, behind the sterile insect technique was to produce some strong and robust male, sterilized male into the wild, which will outperform those who are living in the deserts and somehow weaker. And so, based on the concept that female flies will mate only once, now the great opportunity will come to the male sterile insects or flies, which will ultimately result in the diminishing and elimination of the fly population, and therefore an eradication of the vector. Now in Ethiopia, we are facing the disease and the vector challenges in more than 25,000 square kilometers, especially in the most productive lands of South Ethiopia and Oromia regions. And I'm just talking, because the issue is very devastating, regardless of what we are doing. And I think in the future years, you will get an opportunity to come to Ethiopia and present similar situations so that we can also jointly work together with advocacies, with lobbying ministries, government, higher officials, whatever. And I really appreciate what you have presented. Thank you.
Thank you so much.
Thank you, Dr. Gewado, because then this was also the reason. And so matching Ethiopia and this disease was really good. I just have a question. Perhaps it's more for entomologists and not for veterinarians. But I remember, is it correct that the tsetse flies are particularly aggressive?
Yeah,
because I remember I found one time. I remember in the past I was in the middle of flies, and they were so aggressive that a colleague of mine told me these are the tsetse flies, but they were very aggressive.
And that's why the first clinical symptom is the chancre, which is very, very characteristic, particularly for the tsetse flies. And I read a recent report in the Nature magazine that the behavior of the tsetse flies against the human being has been changed recently, because most of the human beings use the tents and the repellent and the insecticide inside homes. So the usual habit of the tsetse fly is that it bites only inside home. But they noticed that the behavior of the tsetse fly, it changed, and they just bite the human being just after go out from the door. So they are waiting outside the door, and just after go outside the door, the researchers found that this tsetse fly go directly and bites the person just outside the door.
Yes. So therefore, that is curious. So they are not very good. Therefore, we have to kill them. We have to kill them also for this.
Exactly.
But I have another question. Are the same tsetse fly can transmit trypanosomiasis both to human and to animals? So maybe transmit two kind of trypanosomiasis species?
Yes, they can. Whatever they bite, they can transmit it mechanically and also biologically, because the trypanosoma of the human being and also the African trypanosomiasis has a big kinetoblast. It means that they can live outside their host for a long time and can also make a reproductive cycle in the tsetse fly. And this is the complication of the human African trypanosomiasis, that the wildlife play a major role in keeping the trypanosome circulating. So the tsetse fly take it from the wildlife and then go to the human being again.
Yes. Thank you. I don't know whether there are other question from other part of the world, eventually from Asia, because I saw some colleagues from Asia. Otherwise, so usually we don't have a lot of discussion, because we would like to keep the webinar in the 1 hour, 1.5 hours as it was in this moment. Therefore, I would like to thank the two speakers, Beriku and Dr. Alnahrawy. So thank you for having allowed us to have another very, very interesting and challenging webinar. I would like to remind the people that all the webinars are available on the web, on the YouTube channel of our association. Just to inform you that we are in the phase of changing our web page. Therefore, I don't know whether it already worked completely, but during this day it will be completely ready. And I'm sure Beriku, you wrote somewhere, but also Eduardo mentioned to invite Dr. Alnahrawy to Ethiopia. I'm sure
I'll be happy to be there.
Also, because as I mentioned at the beginning, I would like to organize the first Buiatric Congress in Africa. It will be in 2027, because everybody knows that in 2026 we have the World Buiatric Congress in Istanbul, and all participants are invited. Boehringer will be for sure there. no alternative. I know that they already applied for being there. Therefore, but for the African Buiatric Congress, trypanosomiasis will be one of the keynote topics as a congress. Therefore, thank you. I take advantage of this meeting for wishing all of you the best for the forthcoming nativity, for forthcoming festivity. It may be for Christian, Catholics, or whoever, but in any case, the wishing is for everybody, and we finish this year, I think, in the best way, and I hope that we will also start in a similar way, and for sure in the next year we will have very, very interesting webinars and congress. Therefore, I greet all of you. I have many names. So Dr. Kewabo, thank you. Sanusi from Nigeria, and then Professor El Sheri and Mohamed from Tunisia. I'm just going through a little bit. I see also Itagela is from Ethiopia with Mekelle. I saw also Raphael from France. I saw Giulio is from Italy, is my best friend. We were together in Tunisia very recently. Lielti is a young graduate in Ethiopia. I saw also Rosayan from Malaysia, but she has already left. Therefore, thank you, everybody. Thank you, Beriku. See you soon. Thank you, Dr. Alnahrawy. We keep in touch.
Thank you so much.
Boehringer.
Thank you very much.
Merry
Bye-bye.
Christmas.
Bye bye.
Thank you.
Merry
Thank
Christmas.
you.
Bye.
Thank you very much.
Thank you.
Thank you.
Bye bye.